And Wayne is going to be telling us about the path to lowest cost of ownership for micro LED display manufacturing.
So a little bit about Terecircuits. We're a startup company, but the foundational technology, the foundational IP of the company was actually initially developed back as far as 2003 when the first patents were filed. Our founder, Dr. Janice Sheets, was a 20-year veteran of HP Labs. She worked in the OLED space very early on in her career. And today we have progressed to a startup that initially got funded in 2019. We've raised about 5.4 million. And our focus is on advanced packaging and assembly processes and materials specifically for displays and semiconductors. So Terecircuits has 7 granted US patents, and they cover a broad array of different technology areas in packaging and assembly, from interconnects to component placement. And I'll be focusing on component placement for micro LED panel assembly in this presentation. As you have seen in several of the other presentations, and are probably aware by now, one of the challenges in building a micro LED display panel, if you're not building a monolithic panel for something like AR/VR, is to do the pitch conversion and get the micro LEDs separated from the epi wafer and then transferred to the backplane. You can grow it on a backplane. There's a few variations here. You could just use blue micro LEDs and do color conversion. But in general, the challenge is taking the LEDs, using a process like laser liftoff to remove them from the sapphire wafer, and then doing some form of pitch conversion and mass transfer to get the components onto the backplane. There's currently many companies, and again, there's other approaches besides laser approaches, but here's just 4 representative companies that have some type of a laser-assisted mass transfer tool that is available in the market today. So we're seeing a trend and a lot of interest in laser-assisted tools, and in fact, Terecircuits has focused on laser tools for optimizing our process. There's also some flip chip bonders that are used to either complement or support the mass transfer tools for things like bonding. So what needs to happen with a mass transfer tool? What are the objectives? Well, because there's so many components and because they're so small, you need something that's very fast. It has to be very accurate. Some of the pitches that we're looking at and the component sizes can be down to 10 to 20 microns. So you're looking at components that are on the scale of a red blood cell. They need to be handled in such a way that they can be placed accurately. You also need a process that's inexpensive. If it costs too much, you don't have a commercially viable process. And there's other features you'd like to have, like selective release. You'd like to be able to eliminate components that are known bad. Non-contact placement for getting components placed around taller components that may already be in place. And of course, pitch conversion, because for a large-scale display, the fabrication pitch is far too dense for what's required to give you the appropriate pitch for something like, for example, a television. So the goal is also to reduce the capital expense of the tool and maximize the uptime. So a tool that's too expensive to maintain will be unacceptable. And then productivity and yield, of course, are also important considerations. So Terecircuits' approach is to enable these type of improvements with materials. We're a materials company, and we've developed a chemical process that is designed to handle millions of things that are small, thin, and fragile. And in the case of micro LEDs, you're talking about small and require a very precise placement accuracy. So we can use our material and our process with some of these existing tools that you've seen. And we can also develop new tools around the process. And I think in general, the approach is one that will lead you eventually to a much lower cost of ownership. So the 2 laser-based processes that we talk about quite frequently our laser liftoff, which is removing the components from the sapphire